A very good evening to all. Now, today we'll try to solve some numericals. So, the first numerical is about the class A power amplifier, and in the class A power amplifier, you can see the operating point is at the middle of the DC load line. So now what the question is saying that if a series fed directly coupled, so you can see that the efficiency, the maximum efficiency of this class A power amplifier is around 25%, and this question will be having the efficiency below 25%. Now, what this class A power amplifier is doing? This class A power amplifier is supplying a zero point 0.8 watt power to a speaker. Normally, this speaker will be acting as a load. So, this much power is delivered to the load. So, what you can say that this is the power output. So, we have taken this P out is a zero point 0.8 watt. Then, if the supply voltage is 30 volt, now you can see this is the biasing voltage, that is the 30 volt which is given. It means that you are biasing your transistor with this 30 volt, and you are making your transistor to operate in the active region by using a 30 volt, and you are making your emitter base junction forward bias and collector base junction reverse bias by using a 30 volt. And ICQ. Now, ICQ stands for the operating point. So, if you draw the output characteristics of the common emitter amplifier, then this is the operating point. It means that your transistor will be taking this much current from the supply. Fine. It means that your transistor is going to operate for this much current, and this much current is flowing from your transistor, or you can say in the output side of the common emitter amplifier. Fine. So what we can say that this is ICQ is the operating current, and this is the input voltage. So the input power we will have to calculate, that is 30 into 200 milliampere. So if you just solve this, then you are going to have the 6000 megawatt milliwatt, sorry. So you just write in terms of watt. Now, once you got this input power and the output power, you can easily substitute the powers in the efficiency equation, and you are going to have the 13% efficiency. So you can see that the efficiency of this class A power amplifier, which is supplying zero point 0.8 power to your speaker, is having an efficiency of 13%. You can see that 87% power has been lost due to the DC biasing, because it is directly coupled. Now, moving towards the next question, so we'll see that this is just a minute. Hold on. So this is a class A amplifier. It is a single stage class A amplifier, has VCC 20 volt. Then you are having VCEQ 10 volt. Obviously, this ICQ is 600 milliampere. So first we will plot the output characteristics of the common emitter amplifier. So this is what you can say, the output characteristic, that is IC, and this is VCE. Your operating point is I think around 600 milliampere, 600 milliampere. Fine. Then AC output current varies by 300 milliampere. Now, what does it mean? That normally you will have to place your AC output current onto the DC operating point. So this is the reference, that is 600 milliampere, and you will have to superimpose the AC output current above it. So perfectly at you can say symmetrically, we will have to place this AC signal. So this is 600, and this AC output current varies by 300 milliampere. So suppose if you are starting from this point, then this will vary by 300 milliampere. So the reference value is already at 600 milliampere. And this AC output current varies by 300 milliampere. So this point will be at that is the peak point will be at 900 milliampere. Now similarly, if you go in the negative direction, then that will be at 300 milliampere. Fine. So now if you want to calculate the power supplied by a DC source, now the answer is is simple, because the power amplifier, that is VCC into ICQ. VCC means 20 and the operating point is 600 milliampere. Fine. Now you will have to calculate the efficiency of the power amplifier. Now how will you calculate the efficiency? So in that case, you will have to substitute the output power and the input power. So output power will be Vrms into Irms. That is output power. P out will be equals to Vrms into Irms. I think the voltage is not given to us. Only the this waveform is, I think, obtained from the statements. Now, what you can write this Vrms, because RL is given to us, that is Irms into RL into Irms. So that one will be Irms whole square into RL. So you will have to calculate the RMS value. Now, how will you calculate the RMS value? So for that, you will have to move towards our waveform. This is the peak value. So first we will calculate the I peak to peak. So that is IC peak to peak will be equals to what? IC peak to peak, that is 900 minus 300 milliampere. So that one will be 600 milliampere. Fine. Now this is peak to peak, that is positive peak to the negative peak. Now similarly, if you want to calculate only the peak values, so that will be 600 upon 2. Then this is 300 milliampere, and ICRMS will be equals to 300 milliampere upon root 2. So in this way you can calculate the ICRMS. You just have to put the ICRMS value into RL, so that will give you the output power. That will give you the output power. You can see here. Okay, I'll rub it out. Right. This is the 0.72, then 0.72 upon 12. So something, I think around 6% efficiency you are going to get. So these are some numericals of the power amplifier. And if you just apply the concept, you are going to solve the questions on the power amplifier easily. Thanks a lot for the cooperation.